optimized Genesis sequence.
All right, let's get started. Welcome to the session on cruising along with Java, benefiting from the modern features. My name is Venkat Subramaniam. We're going to talk about some of the features in Java since Java 10 onwards to more recent versions. I'll talk a little bit about various different features and how we can benefit from them. We'll start with a quick discussion about the evolution of Java itself, and then we'll dive in and talk about various things. I'll talk a little bit about type inference as well. This is a feature I think we can benefit from, but a lot of us are a bit shy away from using it. But we'll dive in and talk about a few nuances with that as well. And then we'll talk about text blocks, and we'll focus on records. When talking about records, I'll focus on some of the issues with how we create records in terms of writing constructors. So there are some nitty-gritty details that would be useful to know. I'll talk about sealed classes, and then finally, of course, I'll also talk about pattern matching, where we can see the interplay of all these features coming together as well. A lot of these topics I'm talking about, I actually captured them into a book that I'm actually writing right now. I'm actually supposed to be writing that book right now than speaking, but don't tell that to my editor. This is a book that I'm working. It's available in beta, but eventually it'll come out in print once I get my act together and finish the last couple of chapters that I'm still working on. So what I'm going to talk about today is maybe about 40% of what I cover in this book in terms of the topics that we'll be touching on. And so let's get started. So what I want to talk about first of all is evolution of Java itself. If you look back at Java, maybe 10 years and before, the movement in Java had been very slow back in time. There were people like me, for example, standing on the other side of the picket line, constantly complaining that Java is not moving forward, it's very slow. And of course, for me, the biggest change in Java came about in Java 8. When Java 8 introduced the functional programming capabilities, it was clear to me that things were going to be different moving forward. The bigger changes came since then, but one of the things that really remarkably happened in Java was where they decided to change the release cycle. And let's talk a little bit about the release cycle to understand what that really means. And to emphasize this, I'm going to first say Java is agile. But when it comes to agile, we have this misconceived notion in the world, and we think of agile to be very many different things. For example, maybe we are thinking about a month-long sprint or a shorter sprint cycle. That's not what agile really means. And it's great to see the developers behind the Java language have truly embraced the concept of agility. So to me, I would ask the question, what does agile really mean? That's the first question you want to ask. And I'm going to say agile to me means two separate things that are very critical that I often think about. The first one is, it really is a feedback-driven development. So when you're developing software, you want to drive your development based on feedback loops. And feedbacks are enormously powerful. You're able to find out where you are going and then readjust based on how things are progressing. And from that point of view, I would argue the development of Java is absolutely agile. And the second thing I would argue is what is called adaptive planning. And adaptive planning is an extremely important concept for agile development. Unlike what a lot of organizations practice, this is really the true backbone or underpinning of agility. Now, let me tie both of these together in terms of how Java development is happening. And in order to emphasize that, I would first say Java is not being developed on a 6 months cycle. So this is one of the things we need to really keep in mind is Java is not being developed on a 6 month cycle. It's naive to think that everything is happening in Java in 6 months. For example, one of the features we're going to talk about to begin with is type inference that was introduced in Java 10. Type inference took 5 years to implement, not 6 months. And if you look at one of the more recent versions of Java, which has virtual threads, that took them 12 years to implement, not 6 months. So Java is not being developed on a 6-month cycle. However, you can be certain that Java is, in this case, and that's where the emphasis is, Java is being released on a 6-month cycle. And that is the major difference in terms of how Java is being worked on these days. Let's switch back in time to the times of Java 6 and Java 7. They were planning on releasing Java, and what they would do is announce that they want to release a version of Java in 2 years, and then they would announce all the features that would be in that version of Java. Now, everyone in this room clearly knows this very well. Announcing what features will be in a version before you write a single line of code is madness. And we know this because we have experience, because every time we commit to something before we actually do any work, that ends up as a disaster. Well, but that was the practice back in time, and truly they were struggling to release Java. It was taking 4 years, 5 years, 6 years to develop and release it. But why? Because I truly believe the developers behind the Java language are extremely smart, but at the end of the day, they are very smart, but humans too. And guess what you do? And that's not very different from what they were doing. And when they were developing the features, some features would get implemented, but they cannot release them because it's got to be bundled with all these other features into a release. And those people who are working on other features still in development, they would go to them and ask how things are going. And they would give an answer that you and I have given many, many times. And the response was, it's almost done. Well, it's almost done usually means 7 years later. So this did not go really well at all, and they were really struggling. And finally, they decided to do something absolutely remarkable, in my opinion. And the first thing they did was, there's going to be a release of Java every 6 months. On the 3rd Tuesday of March and the 3rd Tuesday of September, 2 releases every year. Since they decided to do this from Java 11, there's been 2 releases of Java, one in March and one in September, every year since then. The second thing they did remarkable is not to commit 100% what's going to be in a release. I think that's absolutely brilliance. And case in point, in Java 12, they were hoping to release the raw string, and about 3 weeks before the release, they withdrew the feature and they reworked on it and released it as a text block in Java 13. That, to me, truly shows this nature of adaptive planning, because after all, if you're not able to adapt to your plan based on reality, there is nothing to be agile about. So that's an example, again, with more recent example of string template, where they decided to withdraw that and rework on it. So are examples of adaptive planning. Not only that, they're releasing the features in Java as pre-releases right now. And as a result, a feature is released as a pre-release at least for 2 releases, so they can get feedback from active use. And based on those feedback, they are making changes as well. So Java development today is both adaptively planned and also is driven by feedback loops. And that's why I say it's truly agile. They're not trying to do foolish things like confining to a set iteration cycle, which a lot of people in the industry do, but instead they are focusing on what I would like to say as true agility. And definitely kudos to the team for doing the right set of planning and adapting the plan along the way as well. So with those new features, there are things we can gain from, and the rest of the talk I'm going to talk about what is it that we can use and how we can benefit from that. But I'm going to start with a bit of a controversial topic, which is about type inference. Now, I think there are only 2 kinds of people in this world: those who love type inference and those who hate it. And I don't think there is anybody in between. And this can be a very polarizing topic, as I figured out. Well, a few years ago, I have this tradition of speaking at the Dallas Java user group every year, and the wonderful people there, tell me to mark my calendar. Usually in August, I go there to speak in the group, and so I often would kind of think about what I'm going to talk about the day before and go give the talk. Well, a few years ago, little did I expect, I was getting ready to travel to Dallas. I was looking at the schedule and I'm asking the question, what am I going to talk about in the meetup tomorrow? And my talk was scheduled for 90 minutes, and I was in a bit of a panic because my topic for 90 minutes was type inference in Java. And I realized I can speak about type inference in Java for 30 seconds. Java has type inference. Thanks for coming for my talk. And I was like, oh my gosh, what am I going to talk about for 90 minutes on the topic? Well, actually, I ended up speaking not for 90 minutes. The talk went for 120 minutes. And at the end of 2 hours, close to 9:30 in the night, we had about 100 people in the room, and the room evenly split with people who love type inference and the people who hate it. And about 9:30, a fight was going to break out. How do you explain to your family you had a bar fight not being in a bar? So that is kind of the odd situation when programmers become really passionate about these technologies. Well, type inference is something I like a lot, but I also want to emphasize we got to be careful how we make use of it. Well, type inference is a feature for statically typed languages. I want to emphasize that. Type inference is a feature in statically typed languages. I know sometimes people can react extremely to things. Like I had one person who looked at the var in Java and literally screamed out saying, oh my gosh, Java is becoming like JavaScript. I want to assure you this for sure. Java will never become evil. So the point really is that Java's type inference has nothing to do with the var keyword in JavaScript. So it is really a type inference in statically typed languages. Languages like Haskell and Scala and Kotlin have had type inference from day one. Languages like C# and even C++ have been moving in this direction, and certainly Java is moving in that direction as well. So Java has been steadily introducing type inference for a long time. People who get agitated about type inference, it's really wicked. For example, I spent about an hour talking about type inference to a group in Boston. At the end of the hour, about 90% of the people in the room were very angry because they're like, we hate type inference, we will never use it. And they were so adamant about this, and they were so particular that type inference was a bad idea. And then after about struggling with them for a while, I asked them a very simple question. And I asked them the question, you have a list, you're writing a for each, and do you write, for example, integer, element arrow, output element, or do you write, for example, simply an element like so, and then you print it out? Which one do you use? And the answer I got was pretty shocking. In fact, I would actually do this here just to kind of get a feel. Let's say this is A. Let's say this is sample B. Raise your hand if you use option A. Just a few people, 2 people. Raise your hand if you use option B, right? That's most of us, right? So the point is, we've been using type inference for a very long time, but we never complained about it. Why? Because they never really introduced to us as type inference. So we quietly, happily started using it. Excuse me. However, with the Java 10, they wanted to introduce this concept of a local variable type inference, but there was a lot of opposition for it because suddenly we felt like we are being given something strange, but I would argue it's not very different from what we have been seeing. So let's talk about a few things we already know to tie this back to what we actually use. So in Java 5, we had generics, and generics gave us a nice way to introduce type inference pretty quietly. So for example, if you were to write integer numbers is equal to new array list, like so, of integer, and you can say numbers.add1, and you can say numbers.add2, and I want to output the numbers given to us. So in this case, the numbers are 1 and 2, as you can see, so not very different from what we would do. But what is the type this function add can take? Well, that information is inferred. Most of the time, you don't have to do the following. But very rarely, you may have to use what is called type witness. I like to call it as a type hint, but they call it as a type witness. A type witness, very rarely we have to write such code. So where, for example, you may say numbers dot integer and then add, and you may add an element like so, and this is using a type witness. If you have not had a chance to use type witness, consider yourselves lucky, because I once worked on a project where I think the code was directly from hell. And for every interface, every call we had to make with generic, we had to make the call with multiple of those angle brackets. It was very, very painful. So if you didn't have to use type inference, that is awesome. I'm sorry, if you didn't have to use type witness, that's awesome. But some of us are not that lucky. We may have to do that in some cases. Now, in the case of Java 7, we all know that we have the diamond operator. So thanks to the diamond operator, you don't have to repeat this twice, and you can simply use the declaration on one side. The information about the type here is inferred for us automatically. That is, again, type inference we have seen. But there was a limitation in Java 7 with respect to what type inference can provide for you. So in Java 7, this code will not compile, so will not work on Java 7, if you will, 7 and Java 8, okay in Java 9 onwards. So essentially, this was a limitation in Java, that if you're using diamond operator, you couldn't use anonymous inner classes. Well, that restriction is gone right now, starting in Java 9, and so we don't have to worry about that. Well, similarly, in Java 8, there was a limitation as well. And there are two limitations that I want to talk about in here. So one limitation is, if you say list of, let's say, 1, 2, 3, and you want to be able to do a dot, let's say in this particular case, you can do a for each, and in the for each you can say a integer, and you could say, for example, element, and then you can output the element like so. So that code works just fine, not a problem. You can also do the following. You can simply say, I want to take on type inference, and I want to drop the type information. That is fine as well. However, if you go back to this code and if you set final, that's perfectly fine. You're allowed to put final right there. However, you cannot put final right here on the other hand. This will not compile. So you cannot, so the limitation is, if you're using type inference, you cannot put things like final. Similarly, if you were to write the code like so and say something like, for example, not null, you are allowed to do so, but you are not allowed to use something like not null. That will be an error as well. So those are limitations in Java 8 when it comes to type inference. Some of that has been eased in Java 11. We'll talk about that. Actually, we'll talk about that right now. So if you're using Java 11, though, as you can see, you cannot put final like so. That's an error. But you can put a var like there in Java 11, and that's perfectly allowed. So as a result, it gives you the flexibility to annotate the parameters, but you're required to put a var in front of the variable for type inference. Well, that's great so far, but let's get a little deeper into type inference. If there is not enough context, Java cannot infer the type. And I want to spend a minute emphasizing this, because I had somebody email me and say, here's a piece of code, Java doesn't understand the type, Java is stupid. Well, I want to emphasize, a lot of times it may feel that something is stupid, but that's usually a reflection of our ignorance rather than the stupidity of what we are targeting. Java is actually extremely smart and powerful when it comes to type inference. But the reason the person said it appears stupid is because the person did not understand how type inference actually works. Type inference requires context. Context makes a big difference. When you have context, you got to use fewer words. For example, imagine I'm walking with my dog, and if I point to my dog and said, that is Buddy. Well, you clearly know what I'm talking about. The name of the dog is Buddy. Well, the context is very clear. If I say, this is my dog, and the dog's name is Buddy, you're going to roll your eyes because it's obvious that you have a dog with you. You're pointing to it. You didn't have to emphasize that it's a dog. It's clear. So the words that this is a dog and the dog's name is Buddy is highly redundant. On the other hand, if I'm on the phone and if I say, hey, buddy, come over here, hey, buddy, and you say, hey, what's going on? Oh, I'm talking to Buddy. It's like, who's Buddy? Well, Buddy could be my friend, but in this case, it could be a friend who's a dog. But I may have to tell you a little bit more about who Buddy is or what I'm referring to. So when the context is missing, you need more information. With context, we need less. But it's important to understand this concept of context in terms of type inference. To understand this, let's take a little example. Let's say I have a person class for a minute, and let's say I have a private string, let's say name, we'll just keep it as a name, and I'm going to say a person, and in this case, let's say a string name, and we'll just simply set name is equal to. Let's go ahead and assign that to the name. And let's also provide just two more things. I'm going to say string get name, which is simply going to return the name. And finally, let's go ahead and say public string, let's say toString, and all that it's going to do is to return the name as well. So that's good enough for our purpose right now. Excuse me, let's go a little bit further with this. And I'm going to say list of person, let's say people equal to list of, let's just take a little example. I say new person, let's say a Sarah, let's start with that. And I'm going to then say over here, a new person will say, we have our friend Bob here and our friend Jill as well. So we got these three objects in this case that we are going to work with. So then I'm going to say, let's get to the interesting part now. So I'm going to say people.stream, and then I would ask it to provide a dot. And let's go ahead and say, in this case, sorted. And then I'm going to say a for each system.out and print line. Let's go ahead and remove the sorted just for a minute. And notice it's Sarah, Bob, and Jill. But I really want them in a sorted order. So I'm going to go back to this and say a person. And I'm going to then provide, let's go ahead and say, here is a comparing, and we'll say a person over here, and this is going to be a person, and arrow person dot get name, and I want to sort this based on the person's name, if you will. So we'll bring in the comparator dot star, but as a static import as well. So in this case, you can see the output is sorted as Bob, Jill, and Sarah in the ascending order of the name. So looking at this code, you say, yeah, that worked really well. However, why not simply drop the type information? Why not simply say person arrow, person.getName? So that works just fine. And as you know, that is type inference working really well for us. And it is telling us, hey, if you look at the word person, you don't know what the type is, but go figure it out. Oh, I figured out the name, that the person is of type uppercase P person, person class. Well, so far so good. Now let's go back to this code. Let's do something a little bit different, if you will. So in this case, I'm going to put a few dashes to discern between the outputs. So I'm going to say, I want to do the sorting all right, but this time I'm going to say dot reversed, and I'm going to reverse that and print that in the reverse order. So when I run the code, you can see it's in the reverse order of Sarah, Jill, and Bob. So that worked really nicely as well. However, now I want to say, why do I bother to provide the type information? Let me get rid of the type information. When I run the code right now, it gives me an error. And the error says, get name on variable person of type object. You say, wait a second. It thinks that person is an object instead of a person. Now, the person that emailed me saying Java is stupid had a problem which is different from this one, but I just created this example inspired by his email claiming Java is stupid. And I want to illustrate this because if we don't understand how type inference works, it can be really frustrating. So it was not hard for me to create an example that mimicked the problem that this person had in the application that he was working in. But why does Java complain at this particular point? If you understand type inference, this becomes very obvious. So let's go over here to understand why this code actually worked. So why did that code actually work when Java was able to infer the type properly? Well, the answer to that question is, look at what the compiler has information on. The compiler looks at that code and says, gosh, I don't have a clue what type person is. So what does the compiler do? The compiler says, all right, we got a stream of person dot sorted, and on this we are calling a comparator, comparing rather, and where comparing takes a function t comma r as an argument, but it also knows that comparing returns a comparator of t. So what that means is you are sending to the sorted a comparator of t. So right there is a comparator of t. And so the compiler clearly knows that t is nothing but a person because the person is obvious from here. So as a result, that is going to be a t. Because we know that sorted takes a comparator of t for this being a type t. So the compiler says, it's obvious to me, I know what t is, it is person. On the other hand, if you take a look at this code that did not work, what just happened? When you look at that code, the compiler once again says, what am I dealing with? Well, comparing takes a function t and returns a r as a result. And in this case, it's going to return from this a comparator of type t. But we are then calling reversed on the result, as you can see right there. We're calling the result reversed on the result. So as a result, the compiler says, you have a comparator t dot reversed is what you're calling. So we went from t to t, no clue what person is. So essentially, looking at what is it being assigned to or what it is being used with, there is no clue to determine what the type is. So the compiler says, look, I looked to my left and I found that sorted is taking a comparator, and I know this is a t and comparator takes a t, so I know that the person is an object of the person class. But in this case, the compiler says, I looked at the details of here, and based on what this is being passed to, it's being passed to reverse, and reverse is not helping me because it takes a comparator, returns a comparator. I don't have enough information to determine what the type is. And of course, you could say, why can't it go one more level and look at what this entire thing is being used? And my answer to that is don't push it, right? There's only so many levels it should go, and it usually looks for the immediate context to determine what that is. So that is why the type inference failed in this particular case. Having said that, though, what's really intriguing here is that did not compile, as you can see, but you don't have to fall back to the original code, even though you could. And instead, you can simply say, here is a method reference, and you can simply replace that with a method reference. And as you can see, that works fine, because the minute you give a method reference, the compiler has enough context to determine what the type is. So the moral of the story is that type inference relies on context to determine a type. Without proper context, it cannot determine the type. That is something we need to keep in mind when we are thinking about type inference. Having said this, a couple of things to really think about. And the first is Java 9 removed the restriction of anonymous inner classes with the diamond operator. With Java 10, we have local variable type inference. So what does that mean, local variable type inference? I'll give you some examples of this right here. So I can say string greet is equal to hello, and I can output greet like so, and you can see that we gave the type. Instead of doing that, you can simply say a var greet equal to hello, and that works just fine. And notice how beautifully we saved 3 characters of typing. Isn't that amazing? Well, clearly, that's not a great advantage. However, imagine having something like, for example, a hash map of, let's say, some domain-specific type, let's say a specific type, and then you have a comma list of some other type, and then of course some variable equal to something. Now when you look at it, look at how much information you had to read. And I often say these are noise in code. Now your eyes are parsing through them every time you look at it, but you're not really benefiting from it as much as you think you do. I'll give an example of this. I just moved to a neighborhood about 2 years ago. The first week, I did not know where the post office is located. So clearly, I looked up the maps. I go near the post office. As I approach it, there's a sign that says, turn right to the post office. Hey, that's great to have that sign. But that sign was useful exactly once in my lifetime. And the minute I knew where the post office is, that sign is useless for me. Now I complain that sign is blocking the beautiful view of the mountains behind it. I would rather not want to have the sign over there. That's exactly the way I feel about type information in code. Well, if you are programming with the code 10 hours a day for the entire week, you know the type most of the time. But what if you're new to the code base? What do? Well, most of the IDEs provide you the type information when you hover over the code. Or you can turn on the setting so you can see the type information in there as well, as not part of the code, but as part of the little feature in the IDE that displays that information for you. So you can do away with the type information quite often, and that can reduce the clutter in your code as well. So you can use this for local variables, as you can see. In addition to this, you can also do the following. Names is equal to list of, let's say, we have Tom, comma, let's say, Jerry, and I can then say a for name coming from names, and I can output the name here as well, like so. So essentially, in this particular case, we can remove the details of the type because that's so obvious to us. We don't have to be providing that. That can be very useful. Likewise, if you use a try, and if you were to say a var file equal to new file reader, for example, and you provide something to it, so that is another thing you can do. The close of the file is going to happen automatically by the try, but more important, excuse me, you're able to use a type inference for that variable without having to say the type entirely. So Java uses type inference for local variables in different forms that can be really beneficial. Java does not have type inference for fields. Somebody asked me why, and my answer is they're just waiting for the riots to die down. And once people get comfortable with type inference, I think there's no reason why they cannot introduce type inference for fields. Java does not have type inference for parameters, and I sincerely hope they never do. Language like Haskell has type inference for parameters, but I'm not a fan of that personally. A language like Scala, while providing type inference for fields, do not provide type inference for parameters, like Kotlin as well, and I hope Java stays that way because I don't think it really helps a whole lot. I want to talk quickly about a few caveats we have to be careful about. Don't use type inference with diamond operator. I wish this was actually an error. So for example, if you write, let's say, integer, numbers is equal to, let's say numbers is equal to new array, list of empty, well, please don't change that to a var. This is a bad idea. Why? Because this numbers is now going to be of type object, list of object, rather than being a list of integer, not what you probably wanted. Similarly, if you have a reference to a base class, and if you modify it to a var, and if it's on the right side a derived type, then the type of the reference becomes derived, maybe not what you want to do. You cannot use type inference to store a lambda expression, because lambda expressions don't have type until you assign them to a functional interface, so you cannot do that as well. So some of the benefits of this is reduced clutter in code. So the code is less cluttered, and who doesn't like less cluttered code? It's easier to evolve the code, easier to reuse the code as well. For example, if somebody is determined that they want to use type inference, I've got an example to rethink about it. So let's bring in the collectors for now. And I'm going to say, here is a list of, let's say, names1 is equal to list of, let's say, Tom, comma, Jerry. And I'm going to then create one more list. We'll call this one as, a different name. We'll call it, in this case, let's say Bob. Let's say Bob and let's say, Paula. So we had two names given here, but I want to be able to group, iterate through them and group them. So I'm going to say names1 dot stream dot, let's say, in this case, collect. And I would say grouping, let's say, by. And in this example, I'm going to say, given a name, I want to say name.char at, and I'm going to get the character at location 0. Similarly, I'm going to write the second one, and I'm going to say this is on names2, and I want to collect them using those names. So you can see the code doesn't have any errors right now. We'll simply say OK, and you can see that in this particular case, it's going to go through with no errors after all. However, I want to reuse this code. So what am I going to do? I'm going to take this back up here and say, hey, this is grouping by. And for the grouping by, I'm going to give it a name grouping equal to. And I will change this to grouping like so. And I will change this to grouping as well. So I can reuse them. So as a result, I'm going to say this is a string name. And I'm going to bring that in there. But the question I want to ask you is, what is the type of grouping? So what should I put over here as the type? Now, I will challenge you. There is probably not a single human in this world who can tell you what the type is. And if somebody does, they don't deserve to live anymore, because they've exhausted all their brain power in finding that particular type of the variable. They become a vegetable after that, right? So the point is, we don't want to spend the time on it. This is a great situation where I'll just call it a var and move on. But I know you're curious. You're saying, but Venkat, I really want to know what that type is. Well, here's a nice idea. You can go to that and do something stupid on it. It's going to give you an error. And guess what the compiler is saying? The compiler says the type of this variable is collector angle string and a question mark. Even the compiler doesn't care anymore. So the point is, there is no reason to dig into those details. It's a fool's errand. There is no reason to look into that closely, because that information is totally useless. So the point really is, we can use type inference for reusing variables or function snippets like that very nicely. It can be a lifesaver when it comes to debugging. And I will not talk about anonymous non-renewable types, because that's not as interesting today, because we have records. We'll look at a variation of that. But having said that, there is one interesting idea, which is type intersection type. I was talking to a group recently, and one person said his team was very reluctant to use type inference until they learned about the intersection type, and they were sold after that. Maybe that can happen to some teams. We'll see what that is. So if I were to say list, let's say in this case of, let's say a var, let's say stuff equal to list of 1.1 comma, let's say hello. So I'm going to then say output stuff, and as you would imagine, it's 1.1 and hello. However, I'm going to say here a stuff dot add new, let's say a sample like so. Now, when you look at this code, some of you may recognize that a list of creates an immutable collection, and this will not work during runtime. It'll throw an exception at runtime that the collection cannot be mutated. However, that is not the problem in this code. You won't even get as far as runtime. This code will not even compile. You're like, really? Why wouldn't that code compile? Well, easy to know. When you try to notice what it says incompatible type sample cannot be converted to int pound 1, where int pound 1 and int pound 2 are intersection type. So what is the type of that? It's a type that extends from object serializable, comparable, constable, and const_desc. So that is actually the inferred type of that variable, and who on earth can create that in their code to such meticulous level? So you can see how smart the compiler is in determining the type. In that particular case, it really distilled it down to the common denominator, which is the intersection type. Now, having said this, it's also interesting to know that var is not a keyword. Now, I don't recommend that you ever do this. Maybe unless you really hate everybody that you work with and you decided to quit your job on the day this is a really good idea. But don't tell them I gave you this idea. You can visualize this in your mind. You hate these people, you quit, and you can walk away throwing the cigarette, and the building burns down, and you walk away. Well, only imagine, don't ever try doing this. So this is the equivalent of it in coding, I think. If you really don't like the program you're working with, go for this. var equal to 100 and output var. And absolutely, why not? And if you really want to mess with their mind, you can even do this. Int var equal to 100, right? Why not? So in different places in the code, you can sprinkle that and walk away. Well, no, don't be cruel. But the point really is, what I like about this is that var is not a keyword. It is a context-sensitive keyword. I'm a big fan of that. So if you already have var in your code, you don't have to worry about conflict with that. That's just fine until you find a day to refactor it. You don't have to rush down to worry about it. Couple of small notes before we go further with this. Java 11 has a way to provide relief for that limitation we saw earlier in the case of Java 8, and that is you can use annotations with var, and as a result, you don't have to worry about really the type inference, and you can put a var in front of it. Now, having said that, I'll just introduce a slight advantage that you have in more recent versions of Java. So let's look at an example of this just to entertain this thought. Now, I'm going to write a silly piece of code to illustrate this, but let's nevertheless try this. So I'm going to say list of, let's say, 1, 2, 3, a bunch of values, and I'm going to say dot stream dot reduce, and I'm going to say a 0 comma, and here I'm going to say, let's call this as result comma and element, and I'm going to say simply return the result, plus 10 as an example. As I promised, it's a very silly example. So I'm going to say a result is equal to, and I'm going to then output the result at the very end of it. So when you look at this code, you can see that it is going to come up with the value. Let's go ahead and say, in this case, this is going to be, let's say, a result. We'll call this as sum, and I'll call this as sum as well. So you can see that's the output we got. But when you look at this code, you look at the function and say, I understand what sum is, great. But what in the world is E? Well, I'm a person who likes to give variable names that are clear and not confusing. So I would normally call this as ignore, like so. And just to emphasize, I'm ignoring it. Well, by saying ignore, you are removing the doubt from somebody saying, gosh, I don't see where E is being used. In fact, it's a more complex expression. They got to keep looking into it. Well, ignore is fine, but wouldn't it be nice to have a more concise syntax? Well, as it turns out, now Java supports what's called an international symbol for I don't care. And this is called underscore. That is the international symbol for I don't care. So you can go back to this code right here, and you can simply use an underscore like so. So this is simply to say that I don't care about that particular variable in that particular location. I'm going to see if this actually works. So let me try this. So let me go back to the code right there and try this one more time. And you can see that worked right now because that was a feature in Java 22, and you are able to use an underscore. Now, similarly, in this case, if you go back to this, and I'm going to just return a 10, and I'm not even using the sum right now. And I'm of the philosophy, if something is cool, use it more often, right? So why not? So you can use underscore multiple times as well. You couldn't have done that, right? So if I said ignore, and if I said ignore, guess what? That's an error. So now I have to say ignore 1 and ignore 2, which really kind of is not very pleasant. But with underscore, you can just keep repeating them as many times as you want to, because you're just simply saying, I don't care. So essentially, that's a filler for a variable which you don't plan to use in your code, and you can use that as well. And that can be very powerful use for type inference as well. So my recommendations are a few. Don't use type inference with the angle diamond operator. Don't put names of types into variable names. Make sure you really understand what it is going to infer to. Specify the type if it's not obvious very well. Use it for temporary and debugging purposes. Use it for reuse. And use it for annotating lambda parameters while you're using type inference as well. So those are some of the recommendations when it comes to type inference and how we can benefit from that. Now, having said that, I will just say one more thing. I consider type inference and text blocks as syntax sugar. What I mean by that is the following. So if you were to look at this example, if I say var greet equal to hello, and I'm going to output greet like so, well, in this case, the compiler literally will modify var with the type. Oh, that's another thing I want to emphasize. If somebody says greet is a var type, no, there is no such thing as a var type. It's really a little wink at the compiler to say, hey, I know the type, you can figure it out, can't you? So that's all you're doing. So just to illustrate this now, if you look at the code, we don't have a string here, we have a var, but if I say javac sample.java and java-p sample.class with the options to display the details, you will notice under the hood, the type in this case is LDC, and it says string hello. So the compiler determines the type to be a string. At the bytecode level, there is no type inference. Type inference happens before the bytecode is generated, and once the bytecode is generated, you have the type information in the bytecode, so there's no type inference happening at runtime. It's purely a compile time mechanism. So with that said, that's why I call it a syntax sugar, because it is really a feature of the compiler, nothing to do with really the JVM itself. The next feature I want to talk about here is the feature of text blocks. Now, before I talk about text blocks, I've used a feature in other languages, and that is called a feature of what are called here docs. And don't get me wrong, I love here docs. But in some languages, when I use here docs, everything works fine until suddenly it doesn't. And I've spent 15, 20 minutes begging for this to work. And you have to figure out that you did not line up something properly. And then when you find it, you're angry because it was so hard to find. Well, what I really appreciate is the developers behind the Java language have taken the time and effort to make this very intuitive for us to use here docs in Java, which is called text block. So before we talk about text block, let's take an example. I'm going to call greet, let's say devox over here, and I'm going to call the greet function. But how do I provide the greet function? Well, let's say public over here, and I'm going to call greet, and I'm going to say name. We'll come to the name eventually, but for now, I want to return a message. But how do I create the message? So I say string message is equal to hello there, and a /n, and then I'm going to say a message plus equal to how are you question mark a /n, and a message plus equal to it is a backslash great backslash double quote seeing you. So, and then of course a /n. I can write code like this, right? So hello there, how are you? It is great seeing you. And I can implement that particular code. But here's a question I would genuinely ask you. Would you do that? Would you put on your resume, I have 15 years of experience using plus equals. I dare you to do that next time. On your resume, in bold font, I got 15 years of using plus equals as an experience. I would say the one who hires you has the best sense of humor to hire you, right? That's a way to know if that's a company you want to work for or not. Well, no, that's not the code you want to write. This is the code you would hide from humanity. This is not what you want others to see. If you have young children at home, this is not what you will show them because they will never, ever take up programming after that. I really wish they had told me this when I was younger. I had small children. They're grown up now, thankfully, but I had small children back then. And when I go home and I start coding, they would come around and I would pick them up, put me on my lap, and I would be coding. I wish people had told me that's not a good idea. And I was coding one day. My little kid was sitting around, looking around, occasionally hitting the keyboard. And then one day, I heard him gasp and said, and I said, oh my gosh, are you okay? And then he looked at me and looked at the monitor, looked at me, looked at the monitor. And then he said, Dad? And I said, yes, dear. And he said, don't worry about it. I'll grow up and take care of you. You don't have to do this anymore. And that's when you know the children begin to read the code. And unfortunately, I am the last programmer in my family. Both of my children have written off, we will never be programmers, because they saw me and said, this ends with you, Dad. So maybe 4 generations from now, there'll be a Subramaniam who is a programmer. But it's not going to happen for 3 generations, I can tell you, right? So this is why it's important to write good code for the family to adopt your profession. Otherwise, you'd be the last person like me to ever have written code in your family. Well, so this is basically where you are not going to be writing code like this because it's really, really very low level, not very much fun. So text blocks make our life a lot easier. When should we use a text block? Well, typically, you're trying to create a document within your code. I do this quite often. I've got applications that send emails to my customers. And when I send emails, I like to send personalized email. If you ever get an email from me, it's not going to say hi. It's going to say hi followed by your name. But that is great as long as you know that I didn't type it actually, because the code generates your name, not me. So I would send emailed to hundreds of people, but very personalized because I got scripts that generate emails with their name, which means I've got to format the text with all the things to fill in, and that is something I need to do quite often. Likewise, you might want to generate JSON data from your application, or God forbid, you may have to generate XML from your application. In those cases, what do you normally do? You typically use the best technology humans have ever created. You copy and paste an XML document or JSON document, and then you modify the fillers to substitute variables. Well, typically when you do that, there are typically going to be empty spaces in the end. And if you have to remove those spaces, that becomes the lowest point of programming, because removing what you cannot see is even more difficult. Now you got to mess with the settings on your IDE to show these invisible characters. Why go through all that trouble? Well, Java makes your life really easy. So going back to this, I'm going to put 3 double quotes right there, and I'm going to get rid of all that silly things that you see around it, and I'm going to remove all of that right there, and I'm going to go back here, get rid of that as well, and you can get rid of all that escapes as well, as you can see. So with that done, I'm going to close the 3 double quotes, and that becomes the multi-line string or the text block, as you can see. Now, what is really cool about text block is it's highly intuitive. So when you look at this code, let's go ahead and output right here a few dashes right there so we can see it. And then I'm going to also do replace all, and I'm going to replace all of the spaces with a tilde so we can clearly see where those appear. Notice there's no tilde, there's no space before that first H, the second H, and the I in the last line as well. So essentially, what you saw here was that Java did not consider these as essential space. Those are really spaces that are part of the indentation, and Java nicely removes it. If you really want indentation, you can provide that, as you can see, and the how is indented, but not the hello and not the it. So in this case, it knows this is not a valid indentation because that is really part of the code indentation, and the remaining part is the essential indentation. So it knows to keep that around very nicely, as you can see. Similarly, I'm going to add white spaces to all these lines. So the line with hello and the line with how both have spaces, as you can see. But the spaces are automatically stripped out. So you don't see any spaces, it removed it. But you say, oh my gosh, I really need the space. You can ask it to preserve it if you wanted to. So now you can see it's preserving the space because you asked it to preserve the space. Similarly, if you want to combine 2 lines, you can do that as well. So in this case, I'm going to just put a backslash, and you can see hello there and how are you are on the same line as well. So it does some amazing ability to provide that kind of a nice way to write a text block, as you can see in here. Now, having done that, we saw the indentation. I call it a smart indentation. You can also see how it's able to remove the white spaces in the end. You're able to preserve it if you need to, which is good as well. And in addition to this, if you really wanted to, you can put all these characters without any escapes, so that becomes really nice. Now, what if I want to replace the word there with a name, if you will? So right there, I say hello %s, and a few different methods have been added. I can do a formatted, and to the formatted, I can provide the name like so, and you can see hello devox in there. So essentially, you can use the formatted to replace all the symbols you normally would use with a printf, so that works really nicely as well. And in addition to this, there are times when you may be creating a large XML document, or you may be creating a large JSON document. And when you create large documents, as you would imagine, you want to indent portions of it. So you can create a fragment of a document and then insert the fragment into a larger fragment. But when you do, if the indentation is off, you're going to get annoyed with it. How do you fix the indentation? The worst way to do it is to manually fix it. That's a lot of work. Well, thankfully, you don't have to do it. You can simply say indent, and you can specify the levels you want to indent. So you can see how it automatically added an indentation. So if I say 5 places, you can see, excuse me, it added the 5 spaces right there for you. So the indentation works automatically. When you say indent, it indents every line using that kind of a, indentation very nicely, as you would see in this particular case. So that is an example of how text blocks work, and we can see the indentation can be used, special characters or escape characters like a /s and a slash. So some of those things you can use. Once again, consider text blocks to be really a concept of syntax sugar. So there is no text block at the JVM level, bytecode level. So the text blocks are replaced by regular strings. So you don't have any runtime performance overhead or any compatibility issues. If you're interacting with multiple JVM languages using the bytecode, there should be no issues because you're just simply using a string under the hood. So that is basically how text blocks work. In my opinion, really nicely done. I'm really happy for it. With that said, I want to talk about records. I also want to talk about some of the maybe idiosyncrasies when it comes to creating constructor for records. And I will mention a few do's and don'ts along the way as well. But let's talk about a record to begin with. So what is really a record? A record, simply put, you can say Java records are really data classes in other languages. So some languages provide what are called data classes. So a data class is intended predominantly to model data. When you create an abstraction, of a class, you often put behavior in your abstraction. But there are times when you really care about a piece of data, and you want to move this data around in your code. That's where records are useful to represent data. How do we benefit from a record? Well, before we try to benefit from a record, let's talk about classes we used to write. So I'm creating a class called person. Well, what do I want to do in the class person? I say private, let's say final string first name. So I'm creating a first name, which is, in this case, a final field. Well, am I done? Well, I would typically create a string first name as a constructor, and I would then say this dot first name is equal to, I would say, first name. Okay, so we create a constructor. Are we done yet? You say, no. You still have to create a public string, get first name, and this is going to return the first name. So you are writing all that extra code. I know what you're thinking. You're thinking, come on, Venkat, we don't do this actually. We write the field, and then we gently right-click on the field name. And before we can blink our eyes, the IDE vomits the rest of the code. Well, unfortunately, you got to live with that vomit forever. That's a permanent vomit, right? And you say, okay, we figured a way to solve that problem. We no longer are using IDE to vomit code. Instead, we are using libraries like Project Lombok. Don't get me wrong, those are amazing libraries. But what we did in the end is we pulled in an extra dependency. And one of the principles I had to follow is to minimize dependencies as much as I can. Well, why can't the language do a better job than having to use libraries or fancy IDE features? Well, good news, Java takes care of that right now. Enters record. So how do we use a record in this case? Oh, as you would know, in this particular example, if I said new person, and if I said Alan like so, the sad part is it produces an output that's of no use. So you still have to write more code after this as well. We're going to fix all of that. So what I'm going to do here is to say person 1 is equal to new person. We'll say Alan, comma, let's say Turing. So I've created a new person 1, and I've created a new person 2 and a new person 3, and we'll change this one to Walker, right? So we have Alan Turing and Alan Walker are 3 different person objects that we have in here. Well, now that we have the 3 person, I want to first start by printing out just person 1. But we got to define a person. How do we do that? Well, I'm going to say record person, and I'm going to say a string in this case, first name, so, and then a string, let's call it last name. So essentially, we created a record called person. It contains a first name, it contains a last name, as you can see. When I run the code, it even gives a meaningful output. But here comes the charm. Records offer a buy 1, get 5 free offer. Isn't that cool? Who doesn't like a buy 1, get 5 free offer? Typically, you get a buy 1, get 1 free offer, right? This wants to provide a buy 1, get 5 free offer. So what are the 5 things that it offers for us? Well, the cool part of this is the minute you buy a record, meaning the minute you create a record, you got all these 5 things. You have a constructor given to you. So the constructor is going to initialize the object. We already saw the constructor in action. You can see new person, Alan Turing. Well, that was a constructor being called, and that is provided for you already. So then you have a getter available for you as well. I can go back to this code and say dot first name, and you can see that I'm able to fetch the first name from that. Now you may look at the syntax and say, hey, that's a little odd, because I would typically expect a get method, like a get first name. Well, the reason I think the first name is better than get first name is, imagine you write a map function. So if you have something along the lines of people.stream.map, and you say person, and you say arrow person.firstname. Well, guess what? You can nicely rewrite this as a method reference. So you can simply say a person and then a first name as a method reference. So when you look at this now, it's a lot more concise. Rather than calling it as a get first name, it's just a first name. It just flows better when you read it out. So that's basically the getter that's available as well as the property or a component name. The third is it automatically provides a toString method. You can override the toString method if you want to, but if you don't, one is provided for you. So if you notice over here, we have person 1, but that is the output from the toString method that you are noticing right there. So it gives you the details that you're able to see right there. And then finally, you also have a equals method and a hash code method written for you also. So in this case, I can not only use that, but I can also say person1 dot equals, let's say person 2, and likewise I can say person 1 equals, and I can say person 3. So clearly in this case, you can see the first is true, the second is not true, and you can see that output as well. So all those are 5 methods written for you: the constructor, the getter, the equals method, the toString, and the hash code given to you. Having said that, there are a couple of things we need to be aware of when it comes to the records. And that is, well, you can also use metadata to extract details about the object, but the extent of, well, first of all, records are immutable. So if you take this particular person 1 that you have in here, and if you were to say, in the case of person 1, I want to be able to, let's say, modify the first name. So I may be tempted to say person 1 dot set first name and be able to say Joe right there. So that's an error. You cannot do that. So set name doesn't exist, and that's an error, as you can see, right? So you are not allowed to do that. That's the first good news. The second is you cannot also do the following. You cannot say person 1 dot first name is equal to Joe. That will not work either. So that's an error, as you can see, and says that it's a private access, you cannot modify it. Likewise, you cannot say a person first name and simply call it like a method, right? With the hope that will allow you to modify it. That's not possible either. So the moral of the story is that records are immutable. Having said that, we got to be very careful and treat this with a great care to make sure it's truly immutable. So let's go back to this code for a second. This is fine. You can write code like this. But the next one is going to be a bad idea. If you say string builder address, so what's the problem with this? While you cannot mutate first name and cannot mutate last name, you can modify what's inside of the instance of a string builder, which means even though the reference is immutable, the object is mutable. That is not a good idea. So you need to honor immutability. So my recommendation is the following. Build a record using first primitives. Because if you use a primitive, like an int or a double, you don't have to worry about that being mutated from the outside, right? Second, 2, using a string. Because the Java string is immutable. So as a result, you can be protected against modification to that particular field, right? So that's better. 3, avoid string builder or any of the objects that are mutable. And a fourth recommendation. So you can do primitive, you can use string, or compose with other well-written records. So if a record has been written really well, that's a great candidate to compose with your another record. So you can build records using records. That's one really nice option in general. So immutability is limited to what you add to the property or component. There are some built-in methods you can use, especially using reflection. You can find these different components at runtime, but there are some restrictions. There are 2 restrictions you should be aware of. The first restriction is you cannot extend a record from anything. So for example, a record, let's say in this case a pair, and I'm going to say this is a pair of 2 values, and I'm going to say int a comma int b. So there are 2 pairs of integer I created, but I'm going to say extends from java.lang.record. Oh, by the way, records already inherit from a record. So the Java lang record is the base type of a record. That's known already. However, if you try to extend from record, you will get an error. Not only are you going to get an error, I think this error is really funny because Java compiler shows an attitude rather than being very kind to you at this point, in my opinion. What would a kind error say? Dear programmer, okay, maybe we can leave the dear. Hey, you cannot use extends because records do not extend from anything. But look at the error, though. The error says curly expected. How rude, right? So it doesn't tell you. You put extends you're not supposed to. Hey, curly expected. What are you trying to do right now, right? So I love that, right? Kind of error message. It's like, I can't imagine you even tried doing this. So no, you cannot put extends. That's what it says. So a pair, but if you're curious about it, right? So notice, I'm going to get rid of this for a minute, all of that. And I'm going to simply go back here and say a record is equal to new pair 1 and 2 and output record. So when you run this code, notice you got a pair. So that shows to us that a pair inherits from record. So that is pretty darn obvious. But you cannot extend yourself record from a record. That's not allowed. Likewise, so records are final by default. Well, that's the only option. So if I say class, my class extends pair. So I want to extend from pair. So when you look at the code, it says cannot inherit from final pair. So pair is final, you cannot extend from it. So inheritance from that is not allowed also. So you cannot inherit your record from something, you cannot inherit something from your record. However, records can implement interfaces. That's perfectly fine. So why? Because you might have, for example, a JSONify interface with a toJSON method, which you can implement in your record and create a JSON representation as an example. So you can implement interfaces, but you cannot extend from a class. That is a restriction that they have for records. So you can implement interfaces, nothing really exciting. You know the syntax for doing this already. That nicely flows through. Having said that, let's talk about construction. Before we talk about construction, I've got a bunch of recommendations. So let's start with a record called location, where the location has a double lat and a double lon. So I have a record which represents some location. I want to create a location. So I say location 1 equal to new location, and let's say minus, let's say 84.23 comma 12. Let's say 56. I have no clue where that is located in the world. Maybe a federal prison, I don't know. And I want to output location 1 right there. So in this particular example, notice it worked. We didn't have to do a lot of work. So this is my very first recommendation. Please do not write a constructor unless you really need one. So essentially, that's my very first recommendation. You say, oh, Venkat, I really like writing a lot of code. Can I please write a constructor? No. I get paid by the number of lines of code I'm writing. Can I write a constructor? No. Instead, write comments and get away with the money. So the point really is, don't write constructor unless you really need to write one. So in an example like this, you have zero reason to write a constructor. Why? Because the constructor is written for you already. Why bother writing a constructor when they wrote one for you? So that's the very first recommendation. Do not write a constructor unless you really need one. Having said that, when should we write a constructor? So we typically would write a constructor if we want one or more of the following. So essentially, you have to work with some capabilities you are interested in. So we typically want to write a constructor if we want one or more of the following. The first one is we want to validate the data given. So if a data is given, you may want to validate it. You may want to say, ooh, you gave me this data, but that's unacceptable. Reject. It's not in the range I want it to be. That could be one reason. A second reason is we want to transform or cleanse data given to us. So essentially, you want to do some data cleansing or data transformation. This would be another time when you would typically implement this. So if you don't have either of these two reasons, don't bother writing a constructor. But these would be the reasons why you would typically want to write a constructor. You say, all right, we want to write a constructor. How do we do that? Well, the first thing I want to emphasize here is that canonical constructors should be, I would say, avoided. So we will see why in a few minutes. So you can write a canonical constructor, but I would encourage you not to do it. You say, wow, if you don't like seeing canonical constructor, is there a time when it might be okay to see a canonical constructor? And I would say, yes, that is, you have legacy code and you decided to take an existing Java class and you want to refactor it into a record. And you are in the middle of refactoring. You just modified the class to a record. You took the fields and moved them up into the parentheses. And then now you're saying, here's a constructor with a few lines of code, but I don't want to touch it just yet because I like to commit code frequently. So I want to just commit this code and see how it goes. I want to touch the constructor later on. That's a fair game. You can leave that as a canonical constructor temporarily because you're in the middle of refactoring legacy code. If you're starting to write a new record, I would not want to see a canonical constructor. Of course, a very reasonable question is, why don't you like canonical constructor? And I want to answer that question, but it's also important to take a break. So I would encourage you to refill your liquids, use the facilities, and when you come back, we'll talk about that and more. Thank you. Thank you. All right. Let's proceed further. Incidentally, I'm awake now compared to before. So that's a big plus. Wow, about 3-ish, it hits you. All right. But whatever I said when I was sleeping, don't care for it. Ignore that. What I'm going to say you now is the truth. So we're going to talk about canonical constructors. And I'm going to say we shouldn't create canonical constructors, but why? Let's take a look at an example to see why that's the case. So here is a location, but I want to do some work with it. As you can see, we can put a try block and a catch exception. Let's go ahead and say EX. I want to output the exception. And in this case, I want to say new location, let's say minus 423.23, comma, let's say 12.56, or whatever that number is. But I want to be able to process that and say, that's not a valid data. So this is where I was mentioning to you two reasons to do this. One is data cleansing, and the other is validation. So to do data cleansing and validation, you might be tempted to write a canonical constructor. So public location, double lat and double lon, and in this case, I want to say if lat is, let's say, less than, well, it's a latitude, so that goes from 0 to 90, right? So we can say if it's less than minus 90, or lat is greater than, let's say, 90, I want to simply say throw new runtime exception, and I'm going to say this is out of the world, right? So we'll throw that exception. So in this case, we want to provide that. But as you can see, this is not complete. The compiler is not going to be happy with me. The compiler says variable lat might not have been initialized. So I have to say this dot lat equal to lat. How boring that is, right? And it tells me that ln is not initialized. So I have to say this dot ln is equal to ln as well. So now the compiler obviously is happy and works. But this is, we're used to, but that's also redundant. There are two problems with this code. The first problem is that is pretty non-redundant. That's obvious, and yet we had to write that code. And I'm a big fan of not writing things that are obvious. The second problem is, look at the noise that we have in here. We pretty much replicated what was on the previous line, and we are repeating that here. In fact, if you were to go back here and change it to LA instead of LAT, you get an error saying the canonical constructor in record is invalid. The parameters have to have the same exact name as well. So that forces duplication in your effort. So in short, this is not very dry. So I want to write a code that is dry. So my recommendation is don't write a canonical constructor. So what should we do instead? My recommendation is to use what is called a compact constructor. So you can remove this from here, and you put a little curly right there, and you can remove all of this, and that becomes a compact constructor. That's much better, isn't it? A compact constructor is shorter than a canonical constructor. You don't have the duplicate stuff in here. So as a result, we said public location curly braces. You didn't have to duplicate that. And you also did not have to duplicate the effort of setting the variables, because that's obvious. It does that for you automatically. So this is so the moral of the story is, do not write a canonical constructor. Instead, write compact constructor. So compact constructors are much better than canonical constructors. So if you have to write one, write a compact constructor, not a canonical constructor. Having said this, I want to say that a compact constructor is really not a constructor. So this is where it becomes a bit more confusing when you look at it. So what is a compact constructor then? So I would say think of compact constructor as a interceptor or a transformer between, I would say, between your call on one hand and the canonical, right? Canonical constructor on the other end, right? So essentially, here's a way to think about it. So if I were to say new location and I provide whatever I want to provide, that's on one end. And on the very opposite end is your canonical constructor that you have on the other side. So think of a compact constructor as an interceptor. So right here, it sits in the middle and it's going to intercept. So this is going to be the intercept the call and do the work. This is the compact constructor. So essentially, a compact constructor sits in the middle, if you will, right in there. That's where it's sitting. So it's not a full constructor. It is really an interceptor that runs between you and the canonical constructor. Why do I want to say it that way? It'll become evident when I give you a slightly more complex example of this. So the code is working fine, but let's go back here and say I want to output new location, this time minus, let's say, 123.32 and maybe 56 point, and I'm going to provide that. That's a lot of characters that I don't care about. So in this particular example, I want to say that, let's go ahead and say 82 right now. So it's a lot of characters I don't care about. So how do I cleanse the data? So to cleanse the data, I'm going to go back here and say, hey, I have a ln which is way too many decimal places, so I can say int of ln divided by, times 100, so that pushes by 2 decimal places, and then I convert to an integer and divide it by 100. That gives me the data in a shorter form, right? So we could simply, output that for a second, so we can take a look at it really quickly. So let's go ahead and run that code to just get a sense of what the data looks like. Pardon me. So you can see 56.78, which is ideal. That's what we want. But the question is, how do I set it? Well, logically thinking, what would you do? You would say this dot ln is equal to that particular value, right? That's what you would do in a constructor, isn't it? So in a constructor, you would do whatever you want to do and then set that field into that particular object. Well, here's the good news. The first good news is do not set components, fields that you are not not messing with, right? So you are not really messing with the lat. You just validated it, you're done. So don't set that. There's no reason to do it. But the ln is different. How do I set the ln? The error you get right now is the one that will trip you off. When you look at the error, notice what it says. Cannot assign a value to final variable ln. Now, the first thing you will protest is, excuse me, constructor is the only place logically where I would be doing this. Well, sure, you could set this in a in the anonymous constructor initializer, but constructor is where you would typically do this. And it says, cannot assign a value to the final variable ln. So what does that reveal you? That this is really not a constructor. So then what is it? That's why I say it's more of an interceptor. So it's an interceptor that catches you on this transition and says, hey, wait, I'm going to look at the value you're sending. I'm going to do some transformation on it and send it to the real constructor. So once you understand that, it's not that you are okay with the syntax, but at least you understand why the syntax works that way. So what are you going to do to fix it? Rather than that, which is logical, you're going to change it to ln equal to, and you're going to modify the ln itself. Now, I would say that doesn't make a whole lot of sense from the point of view of a function in general, right? Because in general, you would expect the parameters to be final. But in this case, you're actually modifying the parameter, so to say, because it's transforming the data and then passing it down. So essentially what you did is in this code, you are saying, I've got a ln coming into this, and I take the ln, and you transform the ln, and then you are sending it on its course. So essentially, you took the ln, you modified it, and you're sending it forward to the real canonical constructor. That is why that syntax looks very different. So once you accept the fact that a compact constructor is not a constructor, but it's more of a compact interceptor, right? That's what it really is. Then it becomes easier to think about this rather than getting really annoyed by the fact that you cannot change the component or the field. So that is one thing to remember how this actually works. And you can see the transformation taking place, and it's doing the job quite nicely. So we can use the compact constructor, but of course, you can also create non-canonical constructors as well. As an example, if I were to go back here and say new location, and then I'm going to remove that, and of course this will not work because you need to have 2 arguments, not just 1. But we can fix that really nicely by writing a non-canonical constructor. So what I can do here is to say a public location, and I can say double lat, and then within this I can say this lat comma 0, and I can implement that code like so. Now in this case, what's going to happen? The interceptor comes in here, right? So interceptor is called right here. So before you call this, which is the canonical constructor, your interceptor is going to run right there as well, because you're turning around and calling your canonical constructor at this point. So that naturally works really well, not a problem. Now, the last thing I want to show you here is how records can double as tuples. Now, Java doesn't have tuples, but I don't know. You can complain that Java doesn't have tuples, as I do, or you can simply use records as tuples. Now, what do tuples really provide for you? Now, of course, I showed earlier that how Java compiler has an attitude. I'll display my attitude now. I always ask people, why do they call tuple in a weird way? Some people don't call it tuple, they call it tuple. And I don't understand that. If they call it tuple, they shouldn't call somebody they should not call somebody a couple. They should call them cuple. So if you call somebody as a cuple, then tuple is great. But if you tell them they're couples, then tuples is right. That's just my attitude about pronouncing it. So tuples, how do we use tuples? So tuples can be really powerful. What's a tuple? And a collection, an array, or a list usually is a collection of data of the same type. A tuple, on the other hand, is a collection of data of different type that you put together. So essentially, in this case, I'm going to look at an example of using tuples to make the code more expressive. So let's say I have a list of string. Let's call this one as, let's call it as tickers is equal to list of, let's say, Goog, let's say ORCL, and maybe MSFT. So I got 3 tickers. So I want to call a function process and send the tickers to it. So what do I do within the process function? So let's go ahead and say, here is a process function, which takes a list of, let's say, tickers. And what I want to do within this is to print out the price for these different tickers. So I'm going to say that tickers dot stream dot map, and I'm going to take a ticker and call a get price on the ticker, let's say. And then, of course, I want to say for each system.out, and I want to print it. So in this case, I need a function, obviously, which is called get price. So I'm going to say a public, let's say in this case, int. Get price takes a ticker, and all it does here is to return, let's go ahead and say in this particular case, so we'll say return, and we will say in this case, return, let's say a math dot random, let's say times 1,000. So I want to return the values for each of the ticker price. I just realized while creating this example, I accidentally wrote the code that correctly predicts the stock market. So in this case, it's returning this particular value, as you can see, but the result is pretty darn useless. When you look at the result, you say, what are these numbers, right? You can't make sense out of it. So we need more intelligence here. And maybe while we are doing it, we also want to really maybe provide these stickers in the proper uppercase. Maybe we want that also. So how do we go about doing it? So this is where a tuple will be really useful. So I'm going to say this is called a local record. So I can say record, but notice this record is within a function. There's no reason why you cannot create a record globally, but if you don't care for polluting the global namespace and you want only something within your function, you can do that as well. So record stock, in this case, a string ticker and a price, and within this, I'm going to say override, and let's say public string, toString, and all I'm going to do is to return from this one the ticker plus maybe, well, actually, let's do it this way. I'm going to say a %s and a colon %d and dot formatted, and let's say ticker and comma the price itself. So I'm going to provide those 2 values as a response from this particular call to the toString method. So we wrote ourselves a little override public string to string, and we're going to return that value formatted, and that's going to be the format we're going to return from this, and that's what we are providing. Okay, great so far. Now what I want to do here is to say, hey, map, but let's go ahead and say new, and this is going to be a stock with the ticker, comma, the price. And then if we really wanted to, we can then say dot map stock. Oh, by the way, this is where withers in the future will help us. There's a need for us to change only one property of a record. The elegant syntax for that will use what is called a wither. That's going to happen in the next few versions of Java that will elegantly modify select components of a record. But for now, let's simply say new stock, and I'm going to say ticker, which is going to come from the stock. So we'll say stock in this particular case. We'll say dot ticker dot to uppercase. And then I'm going to say simply over here, let's say this is going to be a stock dot price. We'll bring that in as well. And so that's going to be the transformation. And then I want to just print out the stock right after that. So as you can see in this particular case, we are able to take the data and transform it. So this becomes a nice way for us to be able to use a record, a local record, in which case it acts as a tuple, so we can use that as well. So that is basically what you can do with records. So having talked about it, well, let's step back a little bit. We had a good discussion during the break, and I want to kind of expand on that. One of the nice things I love about this idea is the following. Not only is some of these things are beautiful in code, it's got an architectural significance as well. From the architecture point of view, there's something really nice with immutability. And let's think about this for a minute. So what is immutable? Immutable is safe to share. So that is one of the nice things about immutability, right? So for example, if I say that this is immutable, well, guess what? Because it's immutable, I can put that in there, and I can say anyone who wants to share can share it. So multiple of us can hold a reference to it because that is immutable. So because it's immutable, it is very safe to share. So as a result, you can pass it around as reference. You don't have to worry about, oops, I gave them the reference, they mutated it, it becomes immutable. That's one of the nice things. But also what is immutable is safe to copy as well. So if I'm in a distributed system, I have the data locally here. You are on a remote system. You make a request to my system. You get the data, and then you use it and come back to get the data. And you say, gosh, this is pretty slow. Can I cache it on my side to make it faster? Absolutely. It's immutable. It's very safe to cache it on your site. So what is immutable is safe to copy as well. And that's what's so cool about immutability is it is safe to share and it's safe to copy. So you decide what you want to do based on your needs of your application, and it provides you the safety in that particular case. And that is one of the reasons why I like the fact that records are immutable, is they are safe to copy and they are safe to share as well. So it becomes a lot more easier to model applications with it as well. So having said that, let's move on to talk about sealed classes and hierarchy in here. And then after that, we'll talk about a pattern matching with switch expressions and how they help us also. And that would be the last part we'll talk about in this particular section. And then we'll wrap it. Now, obviously, in this case, when we are going to talk about sealed classes, there is a nice things associated with it. There's also a bit of a complexity that comes with it as well. And what I want to do is to really lay the ground as to understanding when we would do things, when it makes sense to do things. That's one of the things I really care about is when I look at concepts, if I feel like they don't make much sense, I really want to understand what is the right use case for those. And if we are able to really nail that down, we can better use these ideas and concepts. Otherwise, we end up creating a mess out of them. And that's why I want to lay the grounds for it so it becomes easier to know the do's and don'ts as well. So we'll get to that in just a few minutes. But let's talk about the concept of sealed to begin with. So what is really the idea of sealed? Well, there are times when you want to create a hierarchy of classes. And when you create a hierarchy of classes, your goal is for others to use your hierarchy, but you don't want them to extend your hierarchy. Why is that? The reason is, from a domain point of view, you might have a certain classes and you want only people to use those classes, not create their own. But you want them to be able to use what's given, but your goal is not for them to arbitrarily create their own stuff. So let's think about that for a minute. Let's say for a minute that we have a power source, let's say. Well, a power source is going to give us a source of power, and maybe in your application, you want to create a bunch of power sources. You are telling your users, maybe you're creating a library, and as a library creator, you have defined a bunch of power sources. You want the users of your library to use those power sources, but you don't want them to create their own power sources. Why not? Well, maybe power sources are a regulated business, and there is a governance, and there's a critical evaluation of the impact of those power sources. There are radiation levels and what have you. And if you want to create your own power sources, you got to get approval from an agency to ensure that it's really safe. So there are some restrictions like that, let's say. So you want to define a power source, but you want other people to use the power sources you create. Now, what are the challenges of telling people they can use what's given, but they shouldn't inherit or extend from it? Well, first of all, if I have a class, I can make the class final, and what's the benefit of it? Nobody can extend from your class. So if I create a class that's final, yay, you can use my class, but you cannot extend from my class. String is a great example of that. You can use a string, but you cannot extend from a string. So classes have nailed it already, right? So good news, you can create classes to your heart's content, you can make them final, and nobody can inherit from it. But what if I created an interface? So interfaces cannot be final. You cannot make a final interface. That's an oxymoron, right? If you create a final interface, that's pretty useless. Why would you even do that, right? So it doesn't make sense to create a final interface and then say nobody can extend from this interface. Like, dude, why are you creating an interface then, right? So that doesn't make a whole lot of sense. So interfaces cannot be final. But the question is, how can we create an interface that we can implement, right? But others can't, except they can use it as is. So in other words, you're saying, I want to be able to create an interface others can use, but I don't want them to implement that interface. Again, why? Because there are reasons why we want to limit what others can do with a set of classes in our system. So the question is, how do we do that? Well, there are hodgepodge of solutions you can create, but almost all of them require either a lot more effort or require checks during runtime, which is not very efficient. Well, enter sealed classes. They call it sealed classes, but it's really sealed classes and sealed interfaces. So when you see the word words sealed classes, don't assume they are sealed classes. They are sealed thingies, right? They're sealed classes or sealed interfaces. That's what they really are. So what am I going to do here? Well, I'm going to first of all say that I want to introduce a power source. So I'm going to say power source is equal to, let's call it power source, is equal to new, let's say solar power source. I'm a big fan of solar power source. I've got a solar power and I don't pay for electricity anymore. I love that. I can use electricity without guilt in my house, right? Because I've got the sun providing. Of course, I also have the advantage. I live in Colorado. We have 300 days of sunshine. So you get sun almost all the time, and so you can benefit from that. I'm a big fan of these natural resources. So I'm going to output my power source right there as well. So I'm going to create a power source, which is a solar power source in this case. So I'm going to go ahead and create a class here called power source, power source.java, and I'm going to say interface power source. And in this case, that's all it is, right? It's an interface. There's not a whole lot to it. And then I'm going to say, take the power source. I'm going to say solar power source.java. So what do I do with the solar power source? I'm going to say final class solar power source implements, in this case, of course, implements the power source. So I made it final. Why? Because I don't want anyone to extend from my solar power source. Obviously, that's the leaf. I don't want anyone to implement from it. So far, so good. So if I go back to my sample code right there, and I'm going to say, go ahead and run that code, excuse me, and you can see my solar power source. That's great. But I'm going to say a final, let's say, well, okay, let's do one more thing before we go any further. So I'm going to, pardon me, I'm going to say, copy solar power source to a wind, let's say, power source. And I'm also a big fan of a wind power source as well, though I don't have a windmill working on it. So in this case, I'm going to say wind power source. And in this case, we got a lot of wind as well. It's almost like being in a storm most of the time. But that's fun too, depending on how you look at it. So we have a final class called wind power source, which implements a power source, right? So we have a wind power source. So going back to the sample code, I've got two power sources right there. That's awesome, and no problem. But I'm going to go ahead and create a class here, which is called my own power source. Now, this is going to implement, let's say in this case, a power source like so. And I will even make it as a final, as a bonus, right? But we are saying, no, that shouldn't be allowed, right? But notice it didn't complain. It did not stop us from creating it. But I'm going to say, no, you're not supposed to create your own. You are supposed to only use what's already there. So the question is, how do we limit that? So I'm going to go back to the power source and say sealed interface power source. So you're sealing the power source, and then you are saying over here, permits solar power source, comma, wind power source. So you are specifying two of those that are allowed to be the children of this power source. So now that you mentioned those two, you have a permission to implement the interface using solar or a wind power. If this was a class, you would simply use the same permits, except they would be extending rather than implementing. No difference. So now I go back to the code and I compile the code. I got an error. Let's read the error. Class is not allowed to extend class power source. You know, it's an interface, right? Extend class power source as it is not listed in the permits clause. So essentially it says you cannot define your own class because it's not in the list of permitted classes. You're not allowed to do that. So as a library creator, you can tell me what the permits is. I can look at it. I can use your interface, but I cannot implement your interface. Why? Because you haven't given me the permits. My class is not part of the permits class. So your implementations can either be in the same package, if you're not using modules, or can be in any package, but in the same module if you're using modules. So there are some nice limitations they provide for it as well. So that is basically what a sealed gives you. There's a metadata you can query, and you can say, hey, is this sealed? and it'll tell you whether it's sealed or not. So there is a class.eSealed you can actually use. So for example, if I go back here and say power source dot get class, let's say dot eSealed, I can ask that question on it. eSealed, it's false because the source solar power is not sealed. But if I say power source dot class dot is sealed, right there you can see that it says a true because a power source is sealed. So you can query for this as well. So if we stop it right here, and you already saw me using the permits, and we talked about the where this can be. If we stop this right now, you can go home happy, right? And you can say, I love sealed. This makes really good sense. But something tells me you don't want to stop right there, right? So this is like watching a thriller movie, right? You know it's going to get horrible, but you still want to hang on to watch it. Well, it's your fault. I cannot help you, but I warned you, right? So what are the things you can specify? This is where it gets a little bumpy. So let's go back and think about what this actually means. Let's say we have this code, everything is fine so far, and we have a solar power and we have a wind power, right? So that's great so far. However, we decide we want to provide a hierarchy in what we are building. So I'm going to say, first of all, a few things. Using final on the child is the most logical option that works most of the time. So this is what I would do most of the time. So as an example, if you look at the solar power, you can see final class solar power. That's the option that makes sense most of the time. So that's the final that you want to use, and that would make really good sense most of the time. Okay, so that's great so far, but what else can we do? So on the other hand, maybe we really want to create a further hierarchy. So what do we have right now? You have the power source, as you know right here, and you also have a solar power source, and you also have a wind power source right now. But maybe these are the children that you have for this right here. But maybe you want not just these two leaves, but another level of hierarchy. So I'm going to say hydro power source, but I want to say model 1 hydro over here and model 2 hydro. So you can see how I'm extending to a second level of hierarchy. So how do I accomplish that? Well, the answer to that question is I can go back here and say a power source permits hydro power source as well. And then I have the solar power source into a hybrid power source. And the hybrid power source basically says it implements solar, but guess what? That is a sealed class hydro power source. So, excuse me, in this case, the hydro says, I'm not a leaf, I've got children as well, so I'm going to be sealed. And so what does it permit in that case? So this permits in this case, pardon me, permits, and what is the permits going to provide in this particular case? I'm going to permit a model 1, we'll call it as a model 1 hydro, and we'll say comma model 2 hydro as well. So notice how this gives a second level of hierarchy. So how does this actually work? So I can take this model 1, so we can say here's the hydro to model 1 hydro.java, and what does model 1 do? That's going to be a final class called model 1 hydro, which extends from hydro as you would imagine. So in this case, we have that particular class written like so. And similarly, I can take the model 1 hydro. Let's take the model 1 hydro and say that it is model 2 hydro. I want to create right there. And that's going to be very similar. So let's go ahead and say model 2 hydro, and that's going to be inheriting from that as well. So if I go back to the sample code right now and say run it, let's see what it tells us. You can see there's no errors, but we just extended it. So this is a sealed, as you can see, right? So what about this? This is final. Like I said, this is the most logical. This is final too. That's also very logical. So are these two, which are final. So that's pretty logical as well. However, this one is sealed. So I think up to this point, it makes really good sense, isn't it? So we understand what final is for, makes a lot of sense. You close the hierarchy, you cannot extend anymore. We understand what sealed means. We wanted to go one more level of hierarchy, but then we seal it after that, so the whole thing is sealed. Up to this point, everything makes sense, except there is one option which is called non-sealed. And you're like, what now? This says, remember we built all this hierarchy? Let's just blow it all out, right? Let's make it unsealed. Now, when you look at it that way, it makes no sense whatsoever, right? It's like, duh, why would you have a sealed and somebody comes and makes one thing non-sealed and walks away? So I like to put logic into what we do. And just on the face value, that doesn't seem logical. But let's look at a use case. So there are two use cases, unfortunately, that are not being met. Remember, there are rules, and you need exception to the rules. Without exceptions, things don't work, right? So there are times when you need exception to the rules. We are doing, let's say, unit testing, and we need to mock or stub the power source. Whoops! How do I create a mock or stub to a power source if it is sealed? Because it says the hierarchy is closed. Hey, I want to create a mock object right now. You can inherit from that class timeout. So I'm like, I really need a way to mock something, so I need an exception to the rule. That's a pretty legitimate situation, isn't it? The second situation is our developers are working hard on inventing new power source, but they have no clue if they will actually work, right? That's very normal. They're like, look, I want to just experiment this power source. We don't know if it's going to work. If it works, we'll go through a lengthy process of evaluating and accepting it, and eventually it can become a regular power source. But what do we do until then? Until then, we need a bunch of experimental power sources, right? Power sources that we can rapidly create and throw away. So guess what? If I want to create a rapid power source this afternoon because I want to play with something that came to my mind, and I'm trying to code it, it says, sorry, you cannot implement this class. Oh, darn it. I've got to go to my architect. Excuse me, can you please put permits for this class for me, please? And they're like, why do you want this? I don't have time for that. I want to just play with this. I want to destroy this at the end of the day. I just want something to rapidly create and play with it because we learn by prototyping. Well, this is too restrictive to keep adding to permits. That doesn't even make sense because you don't want to put in permits stuff that will never go into production or may not even go for a long time. So what you want is that little, intermediate where I want to create a bunch of stuff, but I don't want to make them permanent. So what do? So now you know why non-sealed exists. So non-sealed gives you that breather. Non-sealed says, non-sealed, so you can say, like so, let's try it. So I'm going to say a copy hydro to experimental power source, power source.java, and I say experimental power source.java, so not a sealed, but a non-sealed class, this is going to be experimental, right? Experimental power source. And that implements the power source, as you can see. So now, what are we going to do with it? I'm going to make one change before we go further. So let's go ahead and try this out. So I'm going to say this is going to be the solar power source. I'm going to say public final class. I'm going to take the wind power and the hydro power as well. Let's make that a public class just to emphasize this in here. So then I say the other one that you're going to see in here. So this is going to be the wind power, and that's public. And then I'm going to take the hydro power. I'm going to say public sealed class as well. And then let's go to the power source as well. I'm going to make it a public as well. So far, so good. But I'm going to go back to my sample right now, and I'm going to go ahead and say run. What does it say? Non-sealed class. Let's see. A class is not allowed to extend a sealed class power source. So let's go back to power source and say, I want to permit an experimental power source, right? So we want that to be available, right? That's what we want to do. And now go back and run the code. It's pretty happy. But what is the good news about it? The good news is I can say final class, and let's go ahead and say in here, this is going to be a new power source I want to play with, right? And this is AI-driven power source, right? This is very dangerous. You can't release it yet, but you want to play with it. So AI-driven power source extends experimental power source, right? Actually, let's do something here. I'm going to say power source, and I'm going to say power source, and I'm going to create this final class, and let's go ahead and say implements, right? Implements. So, and in this case, that will not be allowed because obviously that is sealed. But I'm going to say extends experimental power source, and I run the code, and what does that say? It says, cannot find the symbol experimental. Let's make sure I called it correctly. So experimental power source, let's make sure it's actually correct. So go to experimental power source, and that's going to be the experimental power source that I'm interested in implementing. So assuming that that's correct, so let's go ahead and try this out. Oops, implements. So let's go back to this. And this time, I'm going to say, go ahead and use that in here. And what does it say? Sealed interface, power source permits, blah, blah, blah. Oh, I think I made a spelling error. That's what it really is. Let's go ahead and fix it. So let's go back to the power source in here. And here's the experimental power source I'm interested in. Let's go ahead and use that as well. So back to this one. Let's go ahead and try this again. And there you go. So that worked. Now you say, all right, I can see why you need non-sealed, but how do we do that in a way it doesn't defeat everything we did? So here's my recommendation. My recommendation is, please, and I want to put that with an emphasis. So please, and please, do not make your non-sealed a public class. This is all I say as a way to manage this. So yes, go use a non-sealed, but don't make it a public class. Now think about that for a minute. Notice when you look at my solar power, or when you look at solar power is public, but look at my wind power, it's public. But look at my experimental, it is non-public. So what does that mean? All the subclasses I create are within my package, isn't it? Please.
So it's the same as the sealed in Kotlin?
Not necessarily. Not necessarily. So it depends on, sealed in Kotlin would not permit inheritance either. So
You don't need to specify the permits. You just need to have them in the same package.
yeah, but that's more restrictive, right? So in this is a completely different idea we're talking about at the moment. In this case, even in Java, you can have them all in the same file. Then you don't need to use permits. But that's very limited in its capability. But what we are talking about here is, if you make your non-sealed non-public, then it doesn't lend itself for abuse of others. So somebody outside your package cannot extend from your class because a class is not visible to them. It's package friendly or package private. So my recommendation is, if you're creating something that is that is non-sealed, please make that a package internal. By making it a package internal, you get the benefit of using it for testing purposes, using it for experimentation purposes, but you're not opening it for abuse by anybody to overwrite from it. I would frown upon creating a non-sealed which is public as well. So that kind of defeats the purpose, in my opinion. I would rather keep it as non-public, and as a result, you can get the benefit of it without compromising the hierarchy. So that is essentially how you can probably make sense out of how to actually use that, and that could be a way to comprehend and benefit from the feature in a more logical way. So with that said, I want to switch gears to the last part, which brings a lot of these ideas together in a very nice way. And that is the idea of switch expressions and pattern matching. But let's start with an example and work our way to it. So let's say a list of, let's say 55, 66, 77, 88, let's say 99 and 110. And then I'm going to say dot for each, and I'm going to say, in this case, system.out, and let's go ahead and print it, so print line. So we'll start with that first. So those are the values, but I'm going to do a map on this, so a stream dot map, and let's go ahead and say simply sample will call a grade function. So when I call the grade function, what does that provide for us? So a string grade, and I'm going to take a score as a value, and we can do a series of if-else statements in here. We probably all have seen the if-else that keeps on going. Recently, I worked with a client, and this would be funny if this was not true, but I was looking at their code. They had 169 levels of if and else. 169. I looked at their programmers and I said, how do you maintain this stuff? They said, we don't. And that is the problem, right? And their title was changed. They're not programmers anymore. They're victims of this code. And the reason is they didn't write this code. The people who wrote the code conveniently quit. And the people who are holding the code are the people suffering through it. And we refactored it to use a pattern matching. That was much relief, actually. But we don't want to be doing that, so we want to use a switch. Well, switch was and still is a statement. So I'm going to create a statement here. So I'm going to say return the grade, let's say, for, let's say, in this case, score, let's say score, and I'll say is, and let's go ahead and provide the grade like so. So string grade is equal to an empty, and then I'm going to say a switch, and let's say a math.min of score divided by 10, comma 10, and what do I want to do within here? I'll say case, if it is 10, I want to say a grade is equal to an A. Well, what a nice grade. And then I can say over here a bunch of more values. We can say if the grade is a 10, we can say that it's a A. If the grade is a 9, it's a A. If it's a 8 versus a 7 versus a 6, I think that's good enough. And let's change this to a default in this case. So then I can say for a 9, it's a A. For a 8, it's a B. For a 7, it's a C. For a 6, it's a D. And otherwise, it's a F. So seems very logical, isn't it? So the question is, this is way better than using an if-else statement. That's right, isn't it? So this is way better than using a series of if-else. But the question is this good? The first is, it's still verbose. There's a lot of code in there we have to look at. But not only that, it is also error prone as well, and also leads to mutability and hard to reason in general. So this code, after all, is broken, as you can see. Everybody failed this class. That's not a fun course to be in. Occasionally, you run into some courses like this in college, right? Nobody ever passes this course. I'm like, why are you taking it then, right? So that's basically the harsh code. So what happened in this case? Well, we forgot to put a break statement. You got to insert those breaks, and if you don't break, it has an automatic fall through, and that creates a mess out of it. Well, that's your statement, switch statement. The good news is switch can not only be a statement, it can be an expression as well. So to turn this into an expression, the first thing you need is the semicolon. That's a beautiful semicolon to say that's an expression, not a statement. So one easy way to know whether it's a statement or expression, look for the ending semicolon, right? That ending semicolon is needed for being a expression rather than being a statement. So then I'm going to go back here and say, I want to assign this to a switch. So notice, I'm not really creating a variable. I'm assigning the result of a switch to that particular variable. Then I'm going to go ahead and remove all those breaks. So the breaks are gone, as you can see. Then we go back and change this grade is equal to, which is noisy, and let's just get rid of that real quick. So we are not mutating that variable. And then one more, let's just merge them into one-liners. And then finally, we'll replace that colons into an arrow, nothing to do with lambda expressions. So basically, it's much more concise and less error prone, and we don't have mutation in this particular case. So you can see that's producing the result that's desired, but we went from an statement to an expression. So not only can we do this, in addition to doing this, we can also check for multiple cases as well. So you can say 9, 10 in this particular case, and you can remove that from there, as you can see. So as a result, both of those labels are going to match that, so you don't have to duplicate your effort as well. But what if you have to write a multi-line piece of code? Now, I'm not suggesting you do this. Generally, I would group it into a function, but just to illustrate the point, you can put a little curly and you can write multiple lines. So in this case, I'm going to simply say, audit this to check on the status, right? So you can do whatever you want to do within the code, but how do you return from that particular call? Well, the return is not allowed. So you can see you get an error that attempt to return out of a switch expression, that's not allowed. Why? Because are you returning from the switch or are you returning from the function? So you use the yield keyword instead of return to emphasize that you're returning from that particular function, from that particular switch branch. So, but again, like I said, rather than doing this code right here, I would typically call a function rather than putting this kind of code. So my preference would be, I would say handle a case and pass the value to it rather than writing that bulk of code. That would be my preference, right? So rather than putting a bulky code, so when I'm creating the code, I might do that temporarily as an experiment. But once things work, I'll refactor that into a separate method and not have those lines of code in there. But be aware that that's basically possible here for you to put multiple lines as well. So, excuse me. So we can provide those, but what if you have a case where you are interested in a particular type of variable you are interested in handling? So let's come to that separately. And this was created with the intention of supporting pattern matching. But let's take a detour. We'll come back to this in a minute. So I'm going to call a process function, pass a 1, and I want to call a process function, pass a hello to it, like so. But I want to be able to handle these two things separately. So we'll create, in this case, function called process that takes, let's say, input. We'll just keep it generic here as an object type. But what am I doing here? I'm going to return whatever. I don't care about that. Just say whatever right now. But then I say if. And in this case, I say if the input is an instance of integer, then what do I want to do? I'm going to say return got a number, and I'm going to say that I got a number, right? Some processing I want to do for it. But if input is an instance of, let's say, a string, then what do I want to do? Let's say return got a string. So I'm going to say I got a string at that point and return that particular value. So it looks good so far. But I want to say got a string of length, and I want to say length like so. But what is the length? I'm going to say int length is equal to input dot length. So I want to know what the length is. Will that code work? No, you say. Why? Because it says method length is not available on the type object. So we know what to do about this, right? You come down and say a string input, and then you tell the compiler, I want you to treat that as a string and then get me the length out of it, right? So that works. Does anyone remember what that feature is called? Yeah, they call it casting. I call it punishment. Now, think about that for a minute. How do you feel if you have a colleague who is like that? You probably don't talk to them too often, right? Maybe you're walking out the building, you see them in the evening, and you say, hey, how's it going? And they tell you, oh, remember that movie that got released a month ago? I haven't had a chance to see it. I'm going for that movie tonight. Hey, have a great time. The next morning, you see them at breakfast, and you ask them, hey, did you go to the movie? Oh, yeah, I did. And you say, how was it? And they say, how was what? You're like, really, dude? Never mind. Have a good day, right? Because when you ask, did you go to the movie? They say, yes, I did. And when you say, how was it? The it refers to the movie. Let's see what Java did. Hey, Java, is it a string? Yes, it is. What's the length of what? So the question you want to ask is, do you work for the compiler, or does the compiler work for you? And we have been working for the compiler, right? The compiler comes around and says, how's it going? I'm working hard. Not hard enough. Let me check back with you after lunch, and it goes away. Well, we don't want that. So they decided it's time to improve this. So rather than that verbose code, how about simply saying, hey, stir.length, but what in the world is stir? The stir is really a variable you introduce right there. So as a result, you're saying, if input is an instance of string, then give me a stir which is a reference to the same variable, but using a different type. So here's what I want to emphasize, two things. The first is, stir is only visible. Stir is only in scope within this block of code. That's the very first thing. The second thing you need to know is that stir is a string, right? Stir string is referring to the same memory that object input is referring to. In other words, stir double equals input is true. So essentially, they both are referring to exactly the same memory location. So essentially, this is called pattern matching with instance of. You say, whoa, wait a minute. Why is it called a pattern matching with instance of? The reason is, the use case for this is really to use it in pattern matching. We'll see how that is in just a few minutes. So that gives you a nice little instance of. I'm going to copy this so we can take a look at it in a different light a little later on in a few minutes. So let's go ahead and extend this example now. So I'm going to say sealed interface called trade, and then I'm going to say a final class. We will call this one as cell, where it contains a string, let's say ticker, an int quantity, a quantity, and finally we'll also say here is a by, and we will call this as ticker and quantity. So far so good, right? So then I'm going to say output process new cell, let's say ORCL, comma 1000, and I'm going to say a by, and let's say this is going to be, let's say MSFT, and let's say a 500. So in this case, I've got the process function. So public, let's say string process is going to take a trade as an argument. But what does it do? Return switch. And I'm going to say in this case a trade. And let's go ahead and say interface for a while. We'll come back and work with it. And I'm going to change this to a record, and I'm going to change this to a record as well, because that's basically what we are using is a record for those two, right? So record cell and record by becomes a lot easier. So we'll say implements, we'll say implements, in this case, a trade, and similarly, we'll say this implements a trade as well. So then we are going to get to a trade, and I'm going to simply start with the default. And what do I want to do with the default? I'm going to say, in this case, invalid trade. We'll start with that first. That's an invalid trade, right, for that. So let's go fix the error in 15. So that's going to be a print. Let's go ahead and execute the code and see what it wants to provide. So we got an invalid trade. But I'm going to say a case cell, and I'm going to say over here selling. And what are we selling? We'll say cell.ticker plus, we will say a little space, and we'll say cell.quantity, and as to what quantity we are selling. Oops. So let's go ahead and say that right there as to what we are selling as well. So that is our quantity we are selling right there. Similarly, I'm going to say a buy, and that's going to be a buy, and we will say in this case buying, and we will say buying, and that's going to be buy dot ticker, and then buy dot quantity as well. So let's go ahead and provide those two. So here is the buy, and so it is here. So when we run the code this time, you can see cell ORCL and buy MSFT. So that worked really nicely. However, there are a few things you can gain from this by way of how we manipulate this. So this takes us to what's called the data-oriented programming. So rather than creating an object hierarchy, we are able to create a flat processing of different data that's coming in. We can do this, but what is happening in this line of code? This line of code is not very different from, if you will, if the input is an instance of string str. This is really the same use case as this one is. So essentially, in this case, they are checking if the trade is an instance of cell, and if so, they provide a cell as a variable name. So replace this input with trade. So here's a way to think about it. If trade is an instance of cell, then you have a cell as a parameter, as a variable. So essentially the same idea here is that you have the cell coming in. Now in this particular case, when you run the code, it works just fine, but let's make a few different variations to this. The first is, let's say buying ticker, but I don't care about the quantity, let's say. So just to kind of provide a little capability. There's one thing you can do really nicely in here, and that is if I were to buy, let's say, a 5,000 shares, but that needs to be audited. Well, guess what you can do? You can say when buy.quantity is greater than or equal to 5,000, you can say buying large volume. So you can do special ops with it if you really wanted to. So buying large volume, and you can see in this case, it says MSFT, so you can monitor that as well. This is where beautifully a little thing called dominance comes in. So dominance check really says, if you were to reverse these two, that would be incorrect. And the compiler looks out for you and says, listen, you are returning this, you're processing this, but there's one ahead of you that completely hijacks your call. You'll never get to this. So it gives you a warning about the potential error in the code by way of looking at the dominance. So this is, by the way, called the guarded pattern matching. So you can nicely guard it as well. That becomes really nice. Having said this, let's get rid of that for a minute. And back in here, we are able to run that pretty nicely. That's working really nicely so far. But there are a few interesting things we can look for. We match for type, as you can see. But unfortunately, life is not really that simple, because somebody on your team really likes to see the world burn down. So what do? They pass a null to your function. Now, how does that feel when null is given to you? Well, unfortunately, null is a mess. Now, here is an example of what they did for backward compatibility reason. When you look at this code, you say, a null should be handled after all, isn't it? You are right, except switch did not handle null in the past. So this is an example where they preserved backward compatibility to old way of doing things, even though that's not the most elegant. So if you run this code, you literally get a null pointer exception, which you don't want. So what are you going to do? Here's the beauty. You can come down to the code and say case null, and then you can present a nice option to the programmer. You passed null, how dare we will come burn your village, or some friendly message like that, right? You can provide for them. So in this case, you can start handling null specifically in your code as well. And as a result, you can specify how to handle the null, and you can take care of that situation explicitly in your code as well, knowing that if you don't handle null, it'll still result in a null pointer exception. Now that we saw that, there are a few interesting things we can do quite nicely. The first is, there is benefit to having it as a record, and there's a benefit to using as sealed as well. So what are the benefits? The first thing here is, when it is sealed, notice without sealed, I remove the default, I get an error. And the error in this case says, not all possible input values are covered. So if it's an expression, it checks for completeness. And if it's not complete, it's going to give you an error. On the other hand, if I go back here and put sealed like so, then as you will notice, I am not required to write the default. So if I don't write the default, it is quite happy. So that brings up the question. The compiler did not insist on default. Should I write one? The answer is no. Don't write a default if one is not needed. Why? There are two reasons for it. The first reason is, if you write a default, you are putting some implementation without knowing what you should really do for a new type it is added. If they introduce a new one, for example, they introduce maybe one more here, and which is, let's say, a short cell or whatever that could be, they are adding. Well, guess what? Your default is going to handle that in a wicked way, not thinking about the future requirements. If you don't put the default, you will get a compilation error. And I love it, because when you get a compilation error, you're like, whoa, there's a new type added. Let me check with the requirements and find out what our business wants us to do. We can handle it. So that's a good news. So don't write a default. You say, yeah, but that's great. But there's one problem, though. And the problem is, I am the library creator. I added a new class. And way over there is the user of my library, and he is performing the operations, but right in the middle is another library that has the switch. So now I make a change to the code, I recompile it, and he makes a change to the code, he recompiles it, uses a new type, but right in the middle is a library that has the switch that has not been recompiled. Oops, what happens? Here's the good news. If you don't write a default, the compiler writes one for you. So notice, in this code, there is no default, right? I just searched for default. There is none here. So let's leave it at that for a second. I'm going to go over here, compile the code right there, Java P minus C, all those good options, dot class, and I'm going to take the look at the bytecode, and guess what you see in the bytecode? When you look at the bytecode, right there in the middle of it is a default, as you can see. They wrote one for you, going to 44. And what does the 44 do? It says, I'm going to throw a match exception because I came to a situation that's not being matched. So if you don't write a default, they write one for you. And that's going to blow up if you do testing. If you don't do testing, you don't belong in this room anyways, right? So it doesn't matter. No, just kidding. Not really. So the point is that when we test the code, we're going to get a feedback, and we will know that this is not valid. So testing is going to come to the rescue at that point, and that's going to really help us as well. So the moral of the story is, do not write default unless it's absolutely required. Then it's better to handle it that way. So we talked about the matching null. We talked about the completeness check just now, not whether to use default or not. But I'm going to give you two more things that can be really useful. We saw the benefit of sealed, but what about records? Records give you this beautiful idea called destructuring. And destructuring is basically opposite of structuring or construction. So rather than creating an object, you are tearing apart values from an object. So as of now, you can do destructuring on records. Eventually, you should be able to destructure objects as well, but that's around the corner. But let's talk about destructuring and how that actually works. So going back to this code, while this is fine, you can see this is a little bit verbose. So I'm going to go back here and say, this is going to be a string ticker, comma, int q. Just to emphasize, you can modify the name of the variable. So in this case, selling ticker and plus just the quantity q, I can provide that like so. So you can see in this case, it destructured it. Now the key here is to know that you're not sending a ticker, you're pulling the ticker out. So you defined a variable that you're extracting. Now if you're a fan of this like me, I would rather use over here a var rather than a string. And likewise, I would use a var here as well, so you don't have to keep repeating the type information. Should I or should I not? The answer really depends. If you want a very clear verification of the type, say the type. If you say, I don't care to verify the type, whatever it is, I want to just pull in and use it, just use a var as a type inference. So that becomes really nice. Now you say, all right, that's great so far, but what about the next one? For the by. Well, for the by, I'm going to say in here, let's say string ticker, and I'm going to use the ticker like so. Unfortunately, that does not work. Why not? Because it says you have incorrect number of nested parameters. Oh, darn it. I'm going to say int quantity, and when I run the code, you can see that worked. Or if you're like me, you'd have said ignore. Or you know what the international symbol for I don't care is, simply say an underscore. That works a lot better. And why bother to say the type when you don't care about it? Put a var in front of it, and that works really nicely as well. And if you're really saying, I don't care about any of those things, I'm just going to say I am buying and not anything more, you can simply come down here and you can say a var underscore as well, and you can provide that, and you're just buying. But of course, if you want to say you're buying so many tickers, you can always add that in there as well. And you can say buying ticker, and you can use a var for that as well. So that becomes a nice way for you to provide a pattern matching where you're extracting the data, destructuring. By the way, the destructuring can work multiple levels deep as well, not just one level deep. And that's the beauty of it is, if you have a record inside a record, you can simply extract the innermost record very nicely as well. For example, as the arbitrary example here, you can say line, and then you can say point var x1 and var y1, and then you can say comma point var x2 comma var y2, and you are able to extract those. So this is going to extract x1 and x2 of point 1 and x2 and y2 of point 2 from a line. So you can have a nested destructuring as well pretty effectively to get the data out of that as well. That's pretty darn powerful, as you can see. So what you're seeing here is the beautiful synergy between pattern matching, sealed classes, and records as well. And I call them three amigos because they nicely worked with each other, bringing these concepts together very nicely. And that's the power you see of not just pattern matching, but how it nicely works with the ideas of sealed. And as a result, you can automatically check for completeness. When the code evolves, you get a compilation error, which is nice. And similarly, you can also use the record for extracting the data as well pretty effectively. And not only that, as of Java 23, you not only have pattern matching for types, but you also have pattern matching for primitives as well. So you can say not just integer, but int or double. So if you want to do pattern matching for primitives, you can do that also. So that really blossoms to an amazing capability of matching different types of data, including null, and you are able to handle the variety of things that come through. And again, it's up to you whether you want to handle a default or leverage the sealed. And this is also an incentive to use sealed hierarchy as well, because that makes your code a lot more expressive and handle those situations. It's much better to evolve the code by having the completeness as well, which can be really powerful. So I hope that journey of cruising along with Java was useful. Like I mentioned earlier, I'm working on this book on cruising along with Java. We covered about 40% of the topic in this book. If you're interested, take a look at it. Hope that was useful. That's all I have. Thank you.
All systems are nominal. Initialize Genesis.